4 shows us a table and it's saying that the equation y equals to 2 to the power of x over 5 has the given values. We have to find the value of y when x equals to 4. So what I'm going to do is I'm going to substitute x equals to 4 in our equation. So that's going to be y equals to 2 to the power of 4 over 5. 2 to the power of 4 is 16, and 16 divided by 5 is 3.2. So this is our value of y over here. Question 4 part B, we're going to draw the graph of y equals to 2 to the power of x over 5. These are our coordinates, so let's start plotting these. At -1, y is 0.1. So that's going to be over here. Then at x equals to 0, y is 0.2. That's going to be over here. At x equals to 1, y is 0.4. So that is over here. At x equals to 2, y is 0.8. So that's going to be this thing. And at x equals to 3, y is 1.6. So 1.6 is going to be this. And x equals to 3. So this is our point. And then lastly, at x equals to 4, y is 3.2. That's going to be over here. So if we connect these dots now, it's going to be a little rough because I'm going to do it freehand. But this is your graph basically. Then the question says, by drawing a suitable line on the grid, solve 2 to the power of x equals to 6. 5y equals to 2 to the power of x. So 5y equals to 6. Y has to be equal to 6 over 5. Yeah. So we draw a line at y equals to 6 over 5. So that's 1.2. So I'm going to take a different color over here. Y equals to 1.2. And if we draw the line, 1.2 is this one. So this is the line. So our solution for that is going to be this point over here. Let me just draw that clearly. The solution is going to be this point, which is 2.1, 2, 3, 2.5. So x is going to be 2.5 for part C. Basically, what we did was the equation we have is y equals 2 to the power of x over 5. So I multiplied 5 with y, which gave me 5y equals 2 to the power of x. Since the equation they have given us is 2 to the power of x equals to 6, so I equated 6 with 5y, and that gives us y equals to 6 over 5. So this is the line that we have to draw and see what the intersection point is between this line, y equals to 6 over 5, with the curve y equals to 2 to the power of x over 5. And that intersection point is basically x equals to 2.5. D says complete the table of values for 4y equals to 2x plus 1. So 4y equals to 2 times -1 plus 1 will be 4y equals to -1 and y equals to -0.25. Then for x equals to 2, 4y equals to 2 times 2 plus 1 which is going to be 4y equals to 5, and y equals to 5 divided by 4, which is 1.25. On the grid on page 8, draw the graph of 4y equals to 2x plus 1. So, and then we have to find the x coordinates of the points where the line 4y equals to 2x plus 1 crosses the graph. If we plot this to find the intersection, -1 and -0.25 is going to be over here. 1.25 is going to be over here. Then 4 2.25 is over here. So now let's join these. Oh, it's -0.25. My bad. This is over here. This is the point. Okay, yeah, now that makes sense. So this is our line, and intersection point is over here and over here. So that's 3.1235, 3.35, and that is 0.123, -0.35. So these are the two solutions for the intersection between this line and curve. In part D3 are the solutions of the equation a times 2 to the power of x plus bx plus c equals to 0, where a, b, and c are all integers. Use the equations 4y equals to 2x plus 1 equals to y to the power of 2x over 5 to find the exact value of each a, b, and c. So in this part, what we'll do is we'll put both the equations equal to each other. And to do that, we need to make y the subject in the first equation. So 4y equals to 2x plus 1, which means y equals to 2x plus 1 over 4. This is put equal to 2 to the power of x over 5. The reason why we're putting them equal to each other, because it says use the equations to find the exact value of a, b, and c. So intersection points, instead of there's one option of finding the intersection points, that is graphically. The other option is algebraically. So now we're going to use the algebraic route to find the value of a, b, and c. So we cross multiply 4 times 2 to the power of x equals to 5 times 2x plus 1. 4 times 2 to the power of x equals to 10x plus 5. So if we bring it to the other side, 4 times 2 to the power of x minus 10x minus 5 equals to 0. A is 4, B is -10, and C is -5. That's your answer. Question 5 gives us a table of population and area of 3 countries in 2019. Write out the value of the smallest population. Smallest population over here is going to be 2.18 times 10 to the power of 7. Then it says find the difference in area between Sri Lanka and Pakistan. So that's going to be going to focus on this value and this value. So 8.82 times 10 to the power of 5 minus 6.65 times 10 to the power of 4. I'm going to take 10 to the power of 4 common. So going to have 8.82 times 10 minus 6.65. So that's going to be 8.82 times 10, which is 88.2, minus 6.65, 81.58. So 81.58 times 10 to the power of 4. Rewrite this as 8.15 times 10 to the power of 5. This can be further rounded to 8.16 times 10 to the power of 5. So that's your final answer. Then it says, the population density of a country is the number of people per square kilometers. Find the value of the largest population density from these countries. That is going to be South Korea. Why South Korea? Because if you look at the values, we're going to divide a value starting with 5 with a value starting with 1. Whereas if you look at the other ones, something starting with 2 is being divided by something starting with 6. Something starting with 2 is being divided by something starting with 8. So smallest would be 5.17 times 10 to the power of 7 over 1 times 10 to the power of 5, which is going to be 5.17 times 10 to the power of 2, or 517. Part B, it says that in standard form, A equals to 8.6 times 10 to the power of n, and B equals to 1.5 times 10 to the power of n minus 1. Give your answer in standard form and find in terms of n, A minus B. So that's going to be 8.6 times 10 to the power of n minus 1.5 times 10 to the power of n minus 1. I'm going to take 10 to the power of n minus 1 common because that's smaller than 10 to the power of n. So that leaves me with 8.6 times 10 minus 1.5. Why 10? Because we have 10 to the power of n minus 10 to the power of n minus 1. If I'm taking 10 to the power of n minus 1 common, what's left behind is 10. Why 10? Because if you multiply them back, 10 to the power of n minus 1 plus 1 would be 10 to the power of n. So then 10 to the power of n minus 1 is 8.6 times 10, which is 86. 86 minus 1.5 is going to be 84.5. So that's going to be 8.84.5 times 10 to the power of n minus 1, which is going to be 8.45 times 10 to the power of n. Then the second part, it says A times B. So 8.6 times 10 to the power of n times 1.5 times 10 to the power of n minus 1. We multiply 8.6 with 1.5, which is going to give us 12.9, and 10 to the power of n plus n minus 1. So 10 to the power of n plus n minus 1 is going to be 2n minus 1, and that's going to be 1.29 times 10 to the power of 2n in standard form. Question 6 says, Sophia takes part in trio challenge. She walks, then cycles, and then swims. At these distances, walk to cycle to swim as a ratio in its simplest form. So that's going to be 6.3 ratio 3 ratio 1.8. I converted all of them in kilometers. So let's simplify this. 63 ratio 30 ratio 18. I multiplied all of them by 10. So 63 would be 21, 10, and 6. So this is your simplified form, 21 to 10 to 6. Part B says Sophia walks at an average speed of 1.4 meter per second. She completes the walk at 11:05. Find the time she starts walking. So time taken is going to equal your distance
divided by your average speed. So that's going to be 6,300 divided by 1.4. Why 6,300? Because she walked for 6.3 kilometers. So I'm converting 6.3 kilometers into meters by multiplying 6.3 by 1,000, which is going to give us 6,300 meters. The reason why I'm converting this into meters because the average speed is given in meter per second. So 6,300 divided by 1.4 is going to be 4,500 seconds. Now we convert the 4,500 seconds into hours. So for that, I'm going to divide 4,500 by 3,600, and that's going to equal to 1.25 hours. So 1.25 hours is basically 1 hour and 15 minutes. How did we get that? I multiply the 0.25 by 60. So that gives us 15 minutes. Because 1 hour has 60 minutes, so 0.25 times 60 is 15. So now this is the time taken for her to walk. Since we need to find the time at which she started walking, we're going to go back 1 hour 15 minutes from 11:05. So if we go 1 hour from 11:05, that is 10:05. So from 10:05, if we subtract 15, that's going to give us 9:50 a.m. So your time is 9:50 a.m. at which she started to walk. Part C says Sophia cycles a distance of 3,000 meters correct to the nearest 10 meters. She cycles this distance in a time of 450 seconds. So the distance is 3,000 meters correct to 10 meters. Time is 450 seconds correct to the nearest 10 seconds. Calculate the upper bound for her average cycling speed in meters per second. Since we're trying to find the upper bound of her average speed has the formula of distance over time. As the question says upper bound, that means distance has to be the bigger value and time will be the smaller value, which means for distance we find the upper bound and for time we find the lower bound. So upper bound of your distance, we do 3,000 plus 10 divided by 2. 10 divided by 2 gives us the degree of accuracy. And since we're trying to find the upper bound, we add the degree of accuracy. So 3,000 plus 5. So that's 3,005 meters. Then for the distance, we find the lower bound. So lower bound is going to be 450 minus 10 over 2. So that's 450 minus 5, and that is 445 seconds. So now I find the average speed, and this will be the upper bound of average speed. So that's going to be 3,005 divided by 445, and that equals, so 6.75 meter per second is your upper bound of your average cycling speed. Question 7 says, on Monday, the amount of money spent on a website by each customer was recorded. The table shows the results. So we have class intervals for amount of money, and then we have the frequency values. So as you can see, we have an unknown frequency value, which is P for the 0 to 30 interval. The histogram shows some of the results. So we have the frequency density on the y-axis and amount of money on the x-axis. Find the value of P. So if you look at the frequency density for 0 to 30, that is 1, 2, 3, 4, 5. That's 0.5. So frequency density
has the formula of frequency over class width. So frequency density for 0 to 30 interval is 0.5. Frequency is P, and class interval is the difference of 30 and 0, which is 30. So that means 0.5 times 30 is going to give us the p-value, which is 15. Then it says complete the histogram. So let's find the frequency density for each class interval. So for 30 to 40 is already made, so we need to do the last three ones. So for 40 to 50, frequency density is going to be 24 over 10, which is 2.4. Then next one is going to be 19 over 10, which is 1.9. And the third one is 24 over 30, which is going to equal 0.8. So we're going to mark these over here. So for 2.4, that's going to be 1, 2, 3, 4. Just going to draw a line over here first. So that's from 40 to 50. This is 2.4. Next is 1.9. So 1.9 is going to come over here. So 50 to 60 is this. And lastly, 0.8. So that is all of this. I'm going to remove this. So this is your complete histogram. Then they're saying one of these customers is selected at random to receive a discount voucher. Calculate the probability that this customer spent more than $50 on Monday. So more than $50 is 19 and 24. These are the people. So that's going to be, and the total was, we don't know the total frequencies. We have to find that first. So let's start with the total frequency. So we know P was 15. So let's find the total frequency, which is going to be the sum of all of these values. So 15 plus 18 plus 24 plus 19 and plus 24 again. That is 100. So greater than 50 is 19 and 24. So our probability will be 19 plus 24 over 100, which is going to be 43 over 100, or 0.43. The table shows the amount of money spent on a website by each customer on Tuesday. Calculate an estimate of the mean. So this is going to be our X value. This is going to be our F value. So let's start with finding the midpoint of our intervals. So for X value, for the first interval, it's going to be 15. This is going to be 35. This is going to be 45, 55, and this is going to be 75. So now what we do is we use these X values to find sigma Fx. Sigma Fx is the sum of the product of frequency and the X value. X is your mid value of the class interval. So that's going to be 15 times 22 plus 35 times 16 plus 45 times 24 plus 55 times 19 and plus 75 times 14. So that's going to equal, that's 4065. Sigma F is going to be the sum of frequency. So that's 22 plus 16 plus 24 plus 19 plus 14. That's 95. So mean is going to be sigma fx divided by sigma f, which is 4065 divided by 95. And that is going to equal 42.8. Second part says an error was made and one of the sales on Tuesday was not included in the table. That customer spent $41. Tristan says if that value had been included in the table, then the estimated mean would have been higher. Without explanation, explain why he is correct. So if that value was included, it would be included in the 40 to 50 interval. And your mid value in this interval is 45. If the 41 value was a part of this data set, our frequency value would be different then, because there's one more value in this interval. So since the frequency value would change, that would change the overall estimated beat as well. Because for that class interval, there's a higher frequency, which changes the total frequency and the fx value of that class interval. Mid value would still be the same, but it's the frequency value that's changing. Hence, the estimated mean would have been higher than.